All right, it's Thursday already, and it's time for another coding challenge. Well, this stream is for entertainment purposes only, and with further ado, let's jump straight to the coding part. So let's see what's LeetCode got for us today. Pick one. Can we crack it in 40 minutes? Binary gap. Interesting. Oh, it's an easy problem. Okay. Should be able to solve it, although it seems like not too many people like it, which means the problem can be badly formulated. But let's give it a try. Okay, given a possible integer n, find and return the longest distance between any two adjacent ones in the binary representation of n. So we basically transform it to the binary 0, 1, 0, 1s, 1, 1, 0. If there are no two adjacent ones, return 0. Longest distance between any two adjacent ones. Two ones are adjacent if there are only zeros separating them, possibly no zeros. So if there's just 1, 1, so it's, let's say, integer is 3, right? Then the distance what? Also 0. Or it's the same as we don't have ones, I guess. Okay, the distance between two ones is the absolute difference between their bit position. For example, the two ones in 1001 have a distance of 3. Example 22, output 2. Explanation 22 in binary is 10110. Yeah, it seems like, so if it's only 0, meaning adjacent, right? You can jump over 0, 1 to another one. Yes, correct. So we have this one and this one, right? And we really say what? We really say if the distance 2 or distance 1, output 2, 101, and 6, output 1. So if there are two together, right, we still count it as 1. This makes sense. All right. So seems like a little bit of binary operations today. But if we have only one, then the distance is 0. All right. And 0. So n can be any from 1. So it can be negative. It's good. To 10 to 9. All right. Sounds good. So, all right, let's quickly switch to the whiteboard. Right, so the idea is simple. So I guess the algorithm is also straightforward, sort of. So basically, let's say we have what? 5, right? That was the good example, I guess. So this is 4, this is 1, right? So we start with, say, with the rightmost until we hit the first one. Then we start counting distance, right? In this case is, let's say we start counting it. Okay, so next one will be 1. This one will be 2. Until we either find another one, and then we set this to 0. And before we set this to 0, we also do max of whatever current max distance and this value, right? So then finally we will return whatever here. Okay, probably it's not very clear. Let me redo this. I have too much of space here, but of course I can't. I can fit all my thoughts in one corner. Whatever. So let's say we have distance, right? And we do max here. Now I can put max, so I can just put large M, whatever. So then we will return at the end this MD. Sounds like a silly thing. So how do we I would say, transform this to binary? We can, at every single time, we can move it by one bit left side, right side. So until we hit all zeros, right? So once we hit all zeros, obviously there is nothing left. No ones left. Every time we move, right, we do what? We do, so we do AND operation with 1, right? So if this 0 and this 1, it returns us 0. If it's 1 and this 1, it returns us 1. So we can check it as Boolean. So if 1, then pod something here to, let's say, reset the distance. If the distance, and then we have another int current distance, which is 0, right? So if we encounter 1 and current distance is 1, then we have another if else block. Am I having internet connections? I wonder. If internet is still here, right? Seems like it's working. Nope. Maybe not. Whatever. Let's keep going. So in it we have roughly 5-ish minutes past, and we almost cracked it. So an else, right? So if current distance equal to 0, not equal to 0, right? Or we can say greater than 0. It's basically the same thing. We say car dist, we say max distance is max between max distance and current distance. All right. And once we do this, then we say current distance equals 0. Else, so if it was, the current distance is 0 and we encounter 1, we just do nothing, right? So every time we encounter 1, except the first time, we reset the current distance and max. So okay, that's about it. So actually then we don't need another if, we can just say this. So if we encounter 1, but current distance is 0, basically we may ignore it, right? And then once we do this cycle, once we check that, before we exit while loop, we need to shift it. So we need to shift it to the right. How do we shift it to the right? By 1 bit. Right shift the bits on the first operand. So right shift is okay. Should be easy. Let's just say this, like by 1. Let me check examples. All right, it was 101 and we shifted like this by 1. All right. I guess we should say it's to n, right? So we should say n is equal to this thing. Or will it reassign it dynamically? I'm not sure. But let's see. which way is the right way. Right, so we don't need this. It's simplified now, and this is simplified now. So, okay, the idea is straightforward here. Let's start with the example. So because we have time, we can debug it a little bit before running the code, just to make sure that we're on the right side. So let's go with 5. So nothing interesting here. So 5 is greater than 0, so we enter the loop. So we hit first one here, right? So 101 and 001 equals 1 because the first bit matches our mask, right? So we press, so it's equals 1, all right? It's true. And cut distance, I see. No, it won't, it's not going to work because first of all, we do not increment car distance and we should, right? So we still need 1 because we start incrementing at 1. So, okay, let's go this way. Else, so if it was 1, let's say like this. Else, if car distance greater or equal 0, then we do car So the problem is, let's do this. It's just equals to 0. Right, we reset. Should we do this? No. I got it. We still fine with just 1. Okay, so we don't need it. Actually, too much of operations here. But all we need is this. So if n, the last bit in the n is 1, and the current distance is greater than 0, so we init it, let's say, as -1. So we know the first case, right? And current distance greater than 0. No, sorry. Yes, we do need this. Gosh, so many if else. Is it like machine learning program or something? I just wonder. All right. Oops. So if current distance is greater than 0, is one thing. Else if, so, and this is only once, it will be basically just once we first time hit this thing. Is it? No, as if car distance less than 0, right? So it was not initialized, so we never hit the first one. We set car car distance to 0 only, basically. All right. And honestly, do we need this check for car distance? I just wonder. So to me, it sounds like every time we hit the 1, we reset car distance to 0, right? So if it was already 0 and we reset it to 0, nothing have changed. And if it's not 1, all the time we increment. So I see. So every time we increment, but we might start, let's say we have this number, right? What's this, by the way? It's 2 plus 8, so it's 10, right? Looks like, oh no, sorry, 2, 4, 8. Yes, 8 plus 2, it's 10. So let's say we have 10, right, in binary representation. So 10 is greater than 0, but first time we hit the first 0, it's 0, right? So then if it's 1, we still should increment it, right? Or we can just say current distance plus 1, whatever. So we count for this one, if it was already bigger than that. And here, else, so if it's basically 0, we do this thing. We just increment it by 1. So who cares, right? Plus. But the problem though, let's say in this case we incremented, like in this case 10, right? We start, this is what? 10, sorry. And 0, 0, 1, right, gives us 0, because this is 0, and we only get 1 when both this one and this is 1. So it gives us 0, which is not equal to 1, right? Thus, we go here and increment it. So now card distance, let's say if it was initially 0, let's say we start with 0, the card distance gets to 1. And then if we enter next time when this thing is 101, we enter this one cycle, right? It's 101. It's already second iteration. 101 times 1, true card distance at this time is equals to 1, which is greater than 0, right? So we enter here, and then max distance becomes 1, although it's still supposed to be 0 because we haven't hit the first one yet. That's the thing. That's the thing. And in order to hit the first one, and how much time do we have? We have plenty of time. All right, we should start counting card distance only if is greater or equal to 0, right? If it's greater or equal to 0, then we count it. So we initialize it to -1. And that's true. Once we hit it first time, we just say, hey, card distance negative, set it to 0. Then once it's not 1, we say else if here card distance is greater or equal to 0, greater or equal to 0, oops, we do increment it. And once n becomes 0, nothing left interesting, so we can just terminate the cycle and return the max distance. Okay, now it should work. So let me see. Anything else we're missing here? Can we simplify this to look a little bit prettier? So like this. So this is basically just once in a while, right? Or we can, oh, actually we don't care, right? We don't really care until we hit the first one. We can just say while and greater than 0. All right, so yeah, it works, but technically we can just iterate ourselves. We can first iterate n and cut all zeros, and then we don't need this condition. Basically, we can have another while cycle. Just, remove O zeros, left zeros from n, right? And we can add also example here, example 10, which is 10, 10, to 5, which is 101. Right, so we do basically the same thing. First of all, if it's already 0, basically we don't care, right? So what do we do with that? Basically we do this, but we have another check. While this and this, right? So we do, so if this is greater than 0 and so it should be technically negative right here. Oops. And XOR gives us what? Gives us what? We cut everything from 5. Cut this 0, and we shift it to 0, and we never re-enter the cycle and return max distance of 2. Now let's see if it works. All right, we're already like 25-ish minutes to that problem. Okay, it's a wrong answer. All right, let's go with that. So we start with 22, which is this one, right? So what do we do first? We remove it 1, so we should and it's 0. So let's see. So there will be some sophisticated debugging tools. Now let's actually print it out every stage here. So n equals to n. Just to make sure that it does the right thing, right? Gosh, yeah, it was from, yeah, no. All right, I see it. I already see what was the issue. I don't need, which was 10 of this. Oh my God, just one symbol. And the entire program was ruined. Whatever. Okay, let's try and submit because we already did everything to check it. Great. Memory is not great though. Why memory is not great? Something weird always going on with memory in my case. Do I allocate too much of memory? So what do I allocate, by the way? So I'm reusing n here, so it shouldn't be count. So there is one int which is 4 bytes, definitely not 6 megabytes, and what? Another int of 4 bytes, so it's already 8 bytes. Maybe it's too much. I don't know. Yeah, I mean, it's just some weird thing. Let's resubmit a couple of times. I do believe we still will hit 100% all the time. At least just a little bit. Nah, okay, whatever. So 5.9. Oh gosh. So let's return back to the whiteboard. Yeah, sophisticated tools to code the problem. So nice. So today it's a little bit better, I would say. Obviously, it was an easy problem, although it seems not many people liked it. And again, we did it byte-wise. I would imagine people who likes Python and these kind of tools do this, just parsing strings, so they might be a little bit slower than us, but probably better in terms of memory. Not sure. No, I don't know why the memory is always bad. Um, okay, so we hit 100 for the time. Unfortunately, we didn't do the same thing for the memory. Okay, let me maybe resubmit one more time, just last time, and see if it's if it's at least maybe yes, yes, yes. Let me switch. Now we are at 90, basically 5 points from I don't know 30 points. Cool. Yeah, it's just whatever. So yeah, nice. I like it. 95 looks much better. And obviously, we are 195. Okay, you may argue it's 94 because 94.6, whatever. Let's round up. 195. So today is a happy day. Not sure why, but we did it fast. We still have time. So we did it basically in 30 minutes, everything, with explanation, examples, debugging, like everything. But again, the problem was easy, so that's why. So we can proudly put very happy face. Okay, no, it's not. It's a little bit ugly now. All right, looks good. So let's go and celebrate. Let me switch back to the default scene and celebrate this with the fireworks. Do we have it now? Oh, wasted. Too much of wasted. Fireworks. Yeah, 10 hours or whatever. Japanese. Huge collection. Success. So thanks everyone and hopefully see you next time.